In this next video, we are going to be learning about slope and y-intercept in all of its various formats. So for the first 6 problems, we're looking at the equation y equals mx plus b, where the slope is the letter m and the y-intercept is the letter b. So picking out our equation y equals negative 2x plus 6, the mx piece is our slope, so that would be the negative 2, and then the plus b value at the back is our y-intercept. Here we have y equals x minus 7. The mx piece is our slope. There's no number written here, so we know that that is going to be a 1x for the slope, and then it's a minus 7 for the y-intercept, so we write that as a negative 7. For number 3, y equals 2x minus 5 over 2. The mx piece is our 2x, so 2 is our slope. The minus 5 over 2 is our y-intercept, so we write that as a negative 5 over 2. For number 4, y equals 3. There's no mx piece, so we can write that with a slope of 0. The y-intercept is our positive 3 left in the equation. Number 5, y equals 4x. The mx piece is our slope, so we can put 4 in for that value. There is no y-intercept at the back of that equation, so we can put a y-intercept of 0. Number 6, y equals negative 5/9 x minus 3/4. The mx piece is our slope, so that's going to give us a value of negative 5/9. And then the minus 3/4 at the back is our y-intercept, and so we write that as a negative 3/4. For numbers 7, 8, and 9, we are identifying the slope and the y-intercept and then graphing them on the coordinate planes. For number 7, y equals 3/4 x. The mx piece is our slope, so that's going to be 3/4. There is no plus b value at the back of the equation, so that gives us a y-intercept of 0. When we're graphing our equations, our y-intercept value goes first, so we're going to put a point at 0 on the coordinate plane. Then we have our slope 3/4. It is a positive 3/4. Positive means up. And when we're graphing, we always go to the right-hand side. So starting at 0, I'm going to go up 3 and then to the right 4. We can continue that line going the opposite direction. Putting my pencil back at 0, I'm going to go down 3 and then over 4. So that way the line extends both directions. For number 8, y equals negative 3x plus 5. My mx value is going to be my negative 3. My plus b value at the back is going to be positive 5. When graphing, we graph the b value first, the y-intercept. So starting at 0, I'm going to put a point at positive 5 on my y-axis. For my slope, it is a negative 3, so that tells me to go down. We don't have a denominator, so I'm going to fill it in with 1 to go to the right-hand side. So starting at 5, I go down 3, and then to the right-hand side, 1. Down 3 because it's negative, and then to the right-hand side, 1. Down 3 to the right-hand side, 1. I don't need to go the opposite direction in this instance because my line is already at the other edge. For number 9, y equals negative 1/4 x minus 2. The mx piece is our slope, so that's going to be a negative 1/4. The minus 2 is our y-intercept, which puts us at a negative 2. We graph the y-intercept first. Starting at 0, I go down to negative 2 and put my point. My slope is a negative 1/4, so negative means that we're going to go down, and then we always go to the right-hand side. So down 1, and then to the right-hand side, 4. We go the opposite direction to make sure the line hits both edges. So I'm starting back at my y-intercept of negative 2. I'm going to go up 1, and then over 4, continuing my straight line. Continuing on to the back, same process of identifying our slope and y-intercept and then graphing those equations. In number 10, y equals -4. There is no mx piece, meaning there is no slope, so that would be a slope of 0. The -4 or the -4 at the back of the equation is our y-intercept. We're going to graph that y-intercept -4 first. So starting at 0, I'm going to go down and put a point at -4. With a slope of 0, we can't go up or down. It's just going to be a flat line going straight across the entire graph. Number 11, y equals x minus 3. The mx piece is our slope. When there's no number written in there, we fill it in with a 1 value. So that would be a 1 for our slope. And then the -3 would be our y-intercept, and we label that as a -3. When it comes time to graph the equation, we graph the y-intercept first. So starting at 0, we go down to -3 for our y-intercept. My slope is a +1. Positive means we're going to go up. Since we don't have a denominator, we're going to fill it in with 1 going to the right-hand side. So up 1 because it's positive, and then over 1 to the right. Up 1 and over 1, continuing that pattern. Up 1 and over 1 until we get to the edge. Up 1 and over 1. Once we reach the edge, we can connect the dots in a straight line. We want to continue that line going across both directions. So we're going to go down 1 and over 1, down 1 and over 1, down 1 and over 1. Again, continuing that straight line to both edges. Number 12, x equals 2. We can notice that this equation does not start with y. That means that this equation has an undefined slope. It's an unsolvable problem. Undefined means that our slope is going to be a vertical line going up and down. There is no y-intercept available. What we're going to do is we're going to put a point at +2 located on the x-axis. Again, this is an unsolvable problem because it's not starting with our y equals. It's an undefined slope with no y-intercept. The x number is 2. And so this graph is going to run in a vertical pattern straight up and straight down. For numbers 13, 14, and 15, we are identifying our slope and y-intercept to write the equation. So the first thing we want to do is pick out where the line intersects the y-axis. So this is going to be here at +1. So +1 is my y-intercept. In order to find the slope, we want to pick out another readable point. So my next readable point is going to be there at 1, 2. And then we're going to connect our dots in our rise over run pattern. So our ordered pair was 0 and 1 for our y-intercept, and then 1, 2 for our readable point. We can pick other readable points as well, 2, 3. We can do negative readable points if we would prefer. Finding those patterns, 0, 1, and 2 is going up by 1. 1, 2, and 3 is going up by 1. Setting up our pattern y over x, 1 divided by 1 is 1. So that gives us a slope of 1. Putting it all together in our equation, y equals 1x plus 1. Or we don't have to put the 1x, you can just put x plus 1. Either equation is correct. For number 14, we can identify that our y-intercept is crossing our y-axis at +3. I notice that this is a flat line. It's not going up or down, meaning my slope is 0. When we write the equation y equals mx, my answer is 0x, so we don't have to write that, but we do have to put the +3. The equation y equals 3 represents that graph. For number 15, our y-intercept starts at +2 on our y-axis. Picking out our next readable point, I can see that starting at 0, 2, and then going to the next point, 3 and 1, we can find that pattern. 0 to 3 is going 3, 2 to 1 is going 1. Setting it up y over x, so that would be 1 divided by 3. 1 divided by 3 is a decimal, so it would stay its fractional equivalent, -1/3. We can show this with the rise over run fraction. We rise one value and we run 3. And I can see that this is a negative line. So again, that -1/3 is our slope. Writing our equation as y equals -1/3 x, and then +2 at the back. For number 16, our y-intercept is crossing our y-axis at -2. Our next readable point is down here at 1, -5. So setting up our table with 0 and -2, again with 1 and -5. 0 to 1 is going up by 1. -2 to -5 is going down by 3. Setting up the fraction y over x, -3 divided by 1 is a slope of -3. We can show that visually with our slope triangle. I can go down 3 and over 1, so rise over run. Vertical value is 3, horizontal value is 1. That is a negative line as it is decreasing across the graph, meaning the negative slope is appropriate. So -3x for our slope and a -2 for our y-intercept. For number 17, our y-intercept crosses our y-axis at 0. To find our next readable point, it would be at 1 and -2. So to find our pattern, 0 to 1 is going up by 1, 0 to -2 is going down 2. Setting up the fraction, the change in y over the change in x, -2 divided by 1 is -2. We can show that visually with the slope triangle, rise over run. We can rise 2 for our vertical units and run 1 for the horizontal units. And we show that that is a negative slope as that line is decreasing across the graph. Writing the equation y equals -2x, we do not need to put the +0 at the back of the equation. For number 18, our y-intercept is crossing our y-axis at -1. Our next readable point is going to be at 3 and 0. Going from 0 to 3 is going up by 3. Going from -1 to 0 is going up by 1. Setting up our fraction y over x, 1 divided by 3 gives us a decimal answer. As a fraction, it's written as 1/3. We can show this visually by creating our rise over run triangle. We rise 1 and run 3. That line is a positive graph as it is increasing across the coordinate plane. Writing our equation as y equals 1/3 x, and then -1 at the back. For numbers 19 through 21, we are creating our own tables to find our slope values. Going from 5 to -4 is going down 9. Going from 0 to 2 is going up by 2. Setting up our fraction y over x, 2 divided by -9 gives us a decimal answer, and so -2/9 is our slope. For number 20, we're going to fill in our 6 and -6 with our 6 and 2. Going from 6 to 6 is a pattern of 0. Going from -6 to 2 is a pattern of going up 8. Setting up our fraction y over x, 8 divided by 0. If you type 8 divided by 0 in on your calculator, you get an error message, meaning we have an undefined slope. That would be a vertical line going straight up and down, as it is unsolvable. For our last problem, 12(3) and -7(5). Going from 12 to -7 is going down 19. Going from 3 to -5 is going down 8. Setting up our fraction as a change in y over a change in x, -8 divided by -19 gives us a decimal answer, so we use our arrows to convert it back into a fraction, 8/19.